1.2 Trigonometric functions of an acute angle. We're going to look at trig functions initially from a right triangle perspective. And so let's look at a right triangle that we have over here. We'll label the sides first. So angle A, side A is opposite. Angle B, side B is opposite. C, side C would be here. And let's also do this with the names. So if we're in angle A, then this would be the opposite side. Angle A would be adjacent over here, and the hypotenuse is the easier one. That never changes. Okay, so there are 6 sort of definitions you need to be familiar with initially. And the first one is the sine, which is abbreviated sine. And the sine is opposite, which is A over hypotenuse, so A over C. The cosine is the adjacent side over the hypotenuse. So in our triangle, adjacent is B over C. Tangent is opposite over adjacent. So opposite is A and the adjacent is B. The cosecant, which is abbreviated this way, is the hypotenuse divided by the opposite. The hypotenuse is C and the opposite is A. Oh, sorry about that, went the wrong way. The secant of angle A would be the hypotenuse over the adjacent. So that would be C over B, and then finally the cotangent, which is abbreviated this way. Cotangent is the adjacent side over the opposite side. So adjacent would be B over A. Okay, now most of you probably recognize or know some of this by the so, ka, toa part, which would be this way. So the S stands for the sine is opposite over hypotenuse. So the O is the H gives you hypotenuse. The C stands for cosine, and the cosine is then the A stands for adjacent over, not opposite, over hypotenuse. Adjacent over hypotenuse, and the tangent, that's what the T stands for, is opposite over adjacent. Okay, so SOHCAHTOA gives you at least the first couple ones. Then how can you find the other 3? Well, the other 3, so the cosecant, secant, and the cotangent, are reciprocals. So let's see, if we go there, we can still see it. So if you look at the table, if I look at the sine and the cosecant are reciprocals. Okay, and the cosine and the secant are reciprocals. And then finally the tangent and the cotangent are reciprocals. So if you can memorize that, and it's not very hard, but it is a little confusing. The easier one I think here is the tangent and the cotangent. They're reciprocals. They sound like reciprocals. And the way that I do it with the sine and the cosine is the sine is related to, everything is flipped. So the sine is related to the other one that starts with a C. So the sine and the cosecant are related. And the cosine, since it's reciprocal, it's sort of flipped. So the cosine is related to the one that starts with the S. So these are the weird ones, in my opinion. Okay, so these are the sort of the weird 2 that you have to somehow get in your brain. Okay? If you do enough of these, you'll get the hang of this. So then we get this table of reciprocal functions. So the secant what did I just say? The secant's related to the one that starts, the normal one that starts with the C. So the secant's related with the cosine. The cotangent is related to the tangent. The sine is related to the cosecant, because S and C go together. The cosine is related to the secant, and the tangent is related to the cotangent. And you'll see me use that here in just a little bit. Alright, so let's look at this little triangle over here. So, find the 6 trig functions from angle A. So, angle A, so the sine is done for you. Opposite over hypotenuse. So the cosine is adjacent over hypotenuse, right? And we are in angle A, so adjacent is 4 and the hypotenuse is 5. The tangent is opposite over adjacent, so 3 over 4. And then here's where you can use the whole reciprocal thing. So the cosecant is the hypotenuse over the opposite side, and it's the reciprocal of 3 over 5. So you can just flip it. So this one, you just flip the hypotenuse in the adjacent side, and we already have the value here, and that's 5 over 4. The cotangent then would be the adjacent side over the opposite side, and that's 4 over 3. Okay? Find the 6 trig functions from angle B. I did want you to definitely see this one. So now we're in angle B, and that means that we're looking things differently. So for B, this is adjacent and this is opposite. Okay? So the sine of B, and the sine is opposite over hypotenuse, right? So opposite 4 over 5. Okay, and then this one flips to 5 over 4. The cosine is adjacent divided by the hypotenuse, and adjacent would be 3 over 5. So this one flips to 5 over 3, and they already gave us that one, so this one just flips, and that's 4 over 3. Alright, let's look at a couple of special examples here. So we need to find the trig functions for a 45-degree angle. So if that's 45, then this is 1 and that's 1. And then we could do 1 squared plus 1 squared is AB squared, right? So AB would be the square root of 2. Well, this will be a triangle you're going to be very familiar with at some point. So 1 squared of 2 is it's called a special triangle, but you'll see that again down the line. So sine 45, opposite over hypotenuse, right? So opposite is 1 over the square root of 2. I'm okay with you leaving square roots in the bottom, so that's, you don't have to change that. So this is adjacent over the hypotenuse, and that means it's 1 over the square root of 2, still 1 over. And then the tangent is opposite over adjacent. Well, they're the same, and 1 divided by 1 is 1. And then for these, we can just flip them. The cosecant is the reciprocal of this, so it's the square root of 2 over 1, which is usually written as the square root of 2. Same thing over here, and 1 flipped is still 1. Okay, let me go back to something that I said here. I said you could leave the square root in the bottom. There are some textbooks, and I can't remember if our textbook does that, but in calculus, you know, you often don't have to, you rarely have to change this. In pre-calculus, sometimes you do, sometimes you don't. But you're not really supposed to leave a square root in the bottom. So this is called rationalizing a square root. So what you see a lot then is, instead of people writing 1 over the square root of 2, if you multiply the square root of 2 by itself, then you eliminate the square root, right? So the square root of 2 times itself is just 2. Well, that's only fair if you also multiply the square root of 2 times the 1. So because this unit here, this square root of 2 over the square root of 2 is actually just worth 1. So I'm rewriting this in a different notation. So 1 times the square root of 2 is the square root of 2. So this is the other way that you could write 1 over the square root of 2. This is rationalized, and that's very common as well. Alright, another triangle you'll see a lot deals with 30s and 60s. So here are the 30 and 60s. So if you think of an equilateral 60 by 60 by 60, and you cut that right through the middle here, and then you get a perpendicular bisector here, and that's 30, right? So this little triangle here is a 30, 60, 90 triangle. If this used to be 2, and we cut this right in the middle, through the middle, then this is only 1. So the first thing I need to find out is, what is CB? Well, I know that CB squared plus 1 squared, CB plus 1 squared is 2 squared. That's 4, so CB is the square root of 4 minus 1, which is the square root of 3. So this is actually the square root of 3. Alright, so let's look at the sine of 60. So opposite, square root of 3 over the hypotenuse. 2, the cosine is adjacent over the hypotenuse, and the tangent is opposite over adjacent. Sorry, I was trying to think ahead for a second. Square root of 3 over 1, which is just the square root of 3. Flipping gives you these values, and this is why it's nice to think about it as a square root of 3 over 1, so it's easier to flip. Again, this is okay in the top. Some books will make you change this, so and then the way you would change this, so if you multiply by this, top and bottom, so 2 square root of 3 over 3 would be the same as writing 2 over the square root of 3. Okay, so how about the 31 then? So if you want to know what the sine of 30 is, you have to look over here, right? Now this is opposite, and this is adjacent. So the sine of 30 would be 1 over 2. The cosine of 30 would be adjacent, which is the square root of 3 over 2, and the tangent is 1 over the square root of 3. And then you flip these. 2 over the square root of 3, and the square root of 3. Okay. One thing that the book sort of wants you to understand here is that the sine and the cosine are called cofunctions. And what that means is that the sine of 30 is exactly the same as the cosine of 60, because together cofunctions are complementary angles. Complementary adds up to 90, right? So 30 plus 60 is 90, so these two values are the same. Secant and cosecant, same sort of idea. They're always the same. So if the secant of 60 is 20, let's see, 60, so 90 minus 60 would be 30. So if the secant of 60 is 2, then the cosecant of 30 must also be 2. We don't do a lot with that. We'll skip some of the problems that deal with that, but I did want to point that out to you. Alright, last one. A is an acute angle, so that the sine of A is 2 over 3. We need to find the other values. Now the easiest one is this one. We can just flip it, right? Sine is reciprocal with the cosecant. So how do you find the other ones? Well, if the sine of the angle is 2 over 3, then we know that the opposite side relative to the hypotenuse, we know that the opposite is 2 and the hypotenuse is 3. So if I make a hypotenuse of 3, so let's say that's 3, and then that could be 2, and this is the triangle that I'm dealing with this. So I said this one was 2, and then this one was 3, so I must be over here. That must be A, right? Well, if that's 2 and that's 3, then let's say that, well, we don't really need to have B and C here, but we should be able to find this side over here now, because that's an unknown. But we do know that that side squared plus 2 squared is 3 squared. So x squared is 9 minus 4 is 5, so x is the square root of 5. So we know that this is actually the square root of 5. So if the sine of A is 2 over 3, then the cosine is the square root of 5 over 3. And then we can flip it over here. And then the tangent of A would be 2 over the square root of 5, because it's opposite over adjacent. And then the cotangent we can just flip. So this is how you can find all values based on the fact that you have a right triangle, that's sort of implied here in this particular chapter, and one given ratio. Okay, thank you.